Hello guys, now we're going to start a review of linear functions, but starting with some of the aspects that help you recognize whether our relation is a function or not. Basically, when we talk about functions, we know that the inputs have a correspondence with the output, and also that the input has only one output. If it has more than one, I mean that if I have an input value that has more than one output, more than one y value, then that is not going to be a function. Also, we're going to determine if the functions we see here, if they are functions. Let's determine how we know whether that function is linear or not. We have two exercises here, and we have to determine these two things, whether the relation is a function, and if it is a function, we will determine whether it is linear or not. Okay? Well, so let's begin. Here you have this table. You have the input values here with the corresponding output values. And as you can notice, here you see, when it's -1, the output is 8. When the input is 0, the output is 13. When the input is 1, the output is 18, and 2, 23. As you can see, each of the inputs has just one output. It means that we're talking about a function, right? When would that not be a function? Let me give you an example and then I just move on, right? This is an example where you have the same input. Yeah, you have an input with two different outputs. That would not be a function, okay? But we do have a function, and now the second part. So for A, yes, it is a function. Now, B, we need to determine whether it is linear or non-linear. The way we determine linearity is, look at this. The inputs are increasing by 1, so that's the first thing we need to make sure. We are increasing by 1s, and now here is the key aspect of it. It means that we need to see what happens with the y values or the outputs. You go from 8 to 13, from 13 to 18, from 18 to 23. This is what I think you are noticing, that every time you are increasing by the same number, it means that the change is the same or the change is constant. That is the very definition of linear. So, in the case of the first exercise, we have a function that happens to be a linear function. Okay, now let's take a look at the second one. The second one gives you the equation type of it. All right. In this case, we have the variable y, but do you see another variable where you can confront and see if there is a relation? There is no other one. So there is just one variable. This is just an equation, but not a function, because a function needs two quantities, one in front of the other or one related to the other, and see whether that relation is linear or non-linear. But in this case, we don't even have a second variable. So remember, this is not a function. And if it is not a function, I don't even have to bother thinking about whether it's linear or non-linear, because it's not even a function. So that's it. We're done. I write DNA, which means does not apply. That's all. Okay?